Welcome back, folks. Another voltage divider example, and we're gonna look at this backwards a little bit. We're gonna be given the voltage across a resistor, and we're gonna find the source voltage across two things in series combination, including that resistor. So I set up this problem this way, and I changed a couple things about it. We've got a mix of units, so I have ohms and kilo ohms here. I'm going to force you to play with those SI prefixes, and maybe it's a really small signal. So maybe we're dealing with radio receivers or sensors that have very small voltage variation, but we have a 14.4 millivolt signal in that case. We still have to ask ourselves the questions: are these things in series? And we can see that R1 and R2 are in fact in series. And are we relating two voltages? I have the voltage across R2, and I want to relate it to the voltage across both R1 and R2. So it looks like the voltage divider is applicable in this case. So let's go ahead and do it. I'm going to write it out symbolically to begin with, because really what we're getting is one equation with one unknown, and then we just have to solve it in any way that is necessary. So it's not Vs equals, I almost fell for it. It's VR2, okay, the voltage across R2 is equal to Vs, and Vs gets divided across, well, we have the voltage across R2, so that's going to be in the numerator, and then that voltage is divided across R1 and R2. Okay, so that's our canonical form of the voltage divider. And now we just have to make sure we have one unknown. This is our one equation. We want to make sure we have one unknown. So VR2 is 14.4 millivolts. We're solving for Vs in this case. And we have 1.2K over 800 plus 1.2K. Okay, so it looks like I have one equation with only one unknown, so we can solve this, and it's a little bit of algebra to get there, but I think we can handle it. Okay, we bring this whole ratio, we bring it down underneath. So 1.2K over 800 plus 1.2K, and that's going to give us Vs. Okay, so we're still relating voltages. That hasn't changed. It's a voltage divider. We're relating this voltage to this voltage, and they're both across some variation of those series elements. So let's get the calculator to do this for us and bring it up there. Okay, do not maximize. Okay, 1.2K. I got to turn on the calculator. Power saving turned on. Save some battery, I guess. 1.2K divided by 800 times 1.2K. Okay, just another example. If I put in K as E3, I don't have to think about it. And that gives me 1.25 E negative 3. And I'm going to divide that into 14.4 millivolts. Okay, but I'm going to enter millivolts as 14.4 E negative 3, okay, from the millivolts. And let's go up and grab that answer. And we end up with 11.52. What a wonderful round number. That's what happens when I make up examples on the fly. So 11.52. That doesn't feel right at all. Stand by. Did you find my typo? I found my typo. Look right there. That's times. I hope I said plus when I entered it. Okay, let's clean this up. Oh, let's just enter it again. 1.2 E3 divided by 800 plus 1.2 E3. That's going to work out much, much better. 0.6. I like that number. 14.4 E negative 3. I should explain to you why that didn't feel right to me, because that was a little bit of intuition that I think is important to know. Okay, so we're going to divide by 0.6. And that's going to give us 24 millivolts, other than I knew what the answer should be. But something didn't feel right. I got 11.52 was the one where I screwed up. I could edit this video. I could pretend I get the right answer all the time. I would be a liar. Okay? 11.52. Well, my first look at it said, well, that's smaller than the voltage going in. But then I went, no, it's in volts, not millivolts. But that's a very large voltage compared to millivolts. 11.52 volts compared to 14.4 millivolts. Now, these resistors are different, but they're not drastically different. So I wouldn't expect to get close to, or maybe even over a volt, a whole volt, or 15 volts. What was the number? 11 volts? 11.52? I wouldn't expect to get over 11 volts across this resistor. So it just, the magnitude didn't feel right to me. So I took pause. I actually paused the video and went and looked for what I did wrong and figured that out. Okay, but we're still relating voltages. Getting some intuition is good. If this voltage, if these were perfectly equal, they would have the same voltage across them. This one's a little less, so it should actually have a little less voltage across it. It ends up having about 9.6 volts is going to be across that one. Okay, so build that intuition as much as you can. When you're applying the voltage divider, you can relate voltages in either direction. Ask yourself the questions: are they in series, and am I relating two voltages to each other? All right. Whew. Close call. Anyhow, where are we going from this? I'm going to give you some other voltage dividers that don't look like this nice little box, because those are important to look at as well. So stay tuned and good luck.